Okay, welcome back everyone. So in previous case, we are I have introduced the what is Fick's law and its derivation and its analogous to Fick's law. There are two more laws: the Fourier law and the Ohm's law in the heat conduction as well as in the electric field. And now we are we are getting into the derivation of the Fick's law. That is this equation. How he has derived this equation by the considering the discrete atomic jump model. So first of all, consider the crystalline solid. There exists a concentration gradient. Then only we can there is a diffusion. Crystalline solid in which there exist concentration gradient. Okay. So first of all, for our clarification, we are considering the small portion of a concentrations. So where the concentration is changing, that is from C1 to C2. There exists a concentration gradient. Then as we know that the diffusion will takes place from higher concentration to the lower concentration, hence the diffusion direction is towards this side. Okay, but if we consider the atomistic level, there exist two planes. These are the atoms of plane 1, and there exists one more plane, that is plane 2, and we are considering a reference plane. Okay, I'll explain the terms. Okay, this is the and distance between these two planes is considered as alpha. Alpha is known as interplanar spacing. Spacing and so first plane consisting of ni number of atoms, number of atoms in plane 1, and n2 is number of atoms in plane 2, and the volume of this complete thing can be considered as area into length. So we are considering the unit area of cross section, and the volume is equals to alpha. And there is a movement of the atom from plane 1 to plane 2, plane 2 to plane 1, and the flux from plane 1 is considered as J plus for our for our differentiation, and the flux of plane 2 is considered as J minus. And one more term, that is number of successful jumps, that is given as psi gamma. This gamma plus indicates number of this gamma is number of successful jump from 1 to 2 plane. Similarly, gamma minus is number of successful jumps from plane 2 to 1. Okay, this is all about the terms is used in this derivation, and the total number of jumps can be obtained. Total number of the jumps from 1 to 2 is given by per second per unit time is given by this Ni into gamma plus, correct, the number of terms into the its frequency. Similarly, in the case of from plane 2 to 1 is given by n2 into gamma minus. And second thing is concentration in the plane 1, concentration of atom in plane 1 is given by Ci, that is equals to total number of the terms into divided by volume. Volume is nothing but alpha. Similarly, to concentration of the atoms in plane 2 is given by C2, N2 divided by alpha. Correct? Yes. Afterwards, we are using the flux across the plane P. Here, the flux across plane P is given as flux across the plane P P is given as J is equals to J plus minus J minus difference. Then the is equals to Ni plus minus Ni2 into gamma minus. Then we know that N is equals to Ni plus Dn into alpha by 2 and N equal to N2 minus D into alpha by 2. So from here we can get the value of Ni, N1 and N2 in terms of N. N minus Dn divided by dx by alpha by 2 N2 given by N plus Dn divided by dx by alpha by 2. Then we can write this N in the form of concentration gradient, which is a measurable quantity. dc by 2 okay, is it clear? So this concentration equal to N divided by alpha. Previous slide I have explained this one, and differentiating this one will get the value for this one, alpha square divided by dx, dc by dx. Okay, substituting these two value here, equation 1 and equation 2. Substituting these equation 2 values in equation 1, C alpha minus alpha square divided by 2 dc by dx into gamma plus minus C alpha plus alpha square divided by 2 dc by dx into gamma minus. After this one, after making this DC one side and C alpha another side, so rearranging these terms, we can get as minus alpha square gamma plus minus gamma minus divided by 2. Sorry, it is plus, it will become into dc by dx plus c into alpha gamma plus minus gamma minus. So in the absence of external driving force, gamma plus gamma minus equal to gamma. Absence of driving force, gamma plus equal to gamma minus equal to gamma. Then this term will become 0. This will become gamma. Then the flux across JP is given as plane P is given as minus alpha square gamma dou C by dou X. Correct? Yes. Then these two terms can be replaced with the help of my coefficient called as D into Tc by Tx. This is the whole derivation of Fick's first law. Okay? Yes. Next, this is applicable for the single component. So, the Fick's law can also be applied for the multi-component system. If the system consisting of more than two components, then we can apply this Fick's law. How this diffusion will take place and how we can be determining the fluxes with the help of Onsenger's formalism. We will see this Onsenger's formalism in the upcoming classes. Thank you.